Hello, good afternoon, all. Am I audible? Hello, am I audible to you? Okay, we'll start our lecture. So, in our last lecture, you have performed our second practical, that is DDL commands. Okay, and you have created 4 to 5 tables. Okay, so in that tables you have used foreign key, primary key concepts. Okay, and then I have told you to insert values into that tables. Okay, so have you inserted values into that tables? Have you inserted values? I have given you one document also. Okay, and the same value you have to insert in that table. So have you inserted? Have you inserted values? Reply me. Because based on that values only today I will give you some queries. That is the DML commands. And you have to solve that queries. Akshada Deshpande. Akshada. Have you created tables? Have you inserted values? Akshada. Are you not there? Akshada. Madhura. Madhura. Madhura, have you created tables? Have you inserted values? Madhura Badve. Yes or no? Madhura. No reply. Prashant. Prashant.
Yes, ma'am.
So have you inserted values?
Yes, ma'am.
Okay. So any doubt, any error while inserting values?
No, ma'am. I have completed that.
Okay, very good. Okay. What about others? Monali Shinde. Monali Shinde. Are you there? So at least give me reply yes or no. What yes ma'am? Have you completed or not? Okay, let it be. Students are not ready to respond me. Okay. Okay, so we'll start our lecture. I think in our last to last lecture we have covered this point, that is basic query structure. So the basic query structure is having total 3 clauses: select, from, and where. Okay, select is nothing but we are selecting uh, the list of attributes or a single attribute. Okay, from it is for the particular relation, means from that relation we are taking the tuples, okay, and where is nothing but the predicate. And also we have seen that the select, from, and where, these three SQL clauses are related with three other clauses or the three operations of the relational algebra. Okay, so in that the select clause is related with our projection operation. Okay, means in the projection operation also we are selecting the names of the column. Okay, and in the select clause also we are giving or we are selecting the names of the attributes. Then the from clause is equivalent to the Cartesian product operation. Okay, and the where clause is equivalent to the our selection predicate. Okay, so in both the operations we are giving the condition or the predicate. Okay, then we have seen this is the structure of our SQL query. Means while writing any of the SQL query, the sequence should be like this. Means first select statement, then list of the attributes that to be selected, then the from statement. Okay, means from that particular table or from the particular relation we are taking the input, and where P. Okay, so this where, in the where clause we are providing the predicate. So this where clause is the optional clause. Okay, it is not mandatory that every time we need to write the condition. Okay, then we have seen the simple select clause. Okay, so with the help of select clause we can select the name of the attribute. Okay, so it may be the single attribute or we can take the multiple attributes simultaneously. Means suppose I want to find out the names and department names of the instructor. Okay, so I can write here select name comma department name from the instructor. Okay, so it is the simple select clause. Okay, then we have seen some different forms of the select clause, or the different what we can say, the keywords or the different clauses we are using on the select clause. Okay, so so in the select clause we can also use the distinct keyword. Okay, so this distinct keyword it removes the duplicate values. Okay, means if we have written the distinct keyword before any attribute name, means what, if that attribute contains the duplicate values, then the distinct keyword removes all the duplicate values. Okay, and it displays us only the unique values. Okay, then the opposite of the distinct keyword is the all keyword. Means the all keyword it specifies all the values including the duplicate values. Okay, so it is the one form of the select clause. Then we can use the star symbol or the asterisk symbol to select all the tuples, all the attributes from a particular table or from a particular relation. Okay, so the star symbol it is for all the tuples or the all the columns of the relation. Okay, then we can also select a particular literal also. Okay, from a given table. Okay, so for that the syntax is we need to write the select clause, and then in a single quote the particular value or any kind of literal we can write there. Okay, and also we can give another name to the particular literal also. Okay, so for that the syntax is select, then the particular literal adds the name what we want to give. Okay, so this adds keyword it is to rename the column or to rename the table. Okay, so if while executing this particular statement, that is select 437 adds FOO, means what, that new table it contains only one column and only one row, and here the name of the column is the FOO, and the value or the row contains 437 value. Okay, so while whenever we are selecting literal, generally a single column and single row is appear as a result. Then we have also seen that the select clause, we can also use different arithmetic expressions in the select clause. Okay, so the plus, minus, multiplication, division, etc. Okay, so we can apply these operations in our select clause. Okay, for example, here the query is that suppose I want to find out the monthly salary of each instructor. Okay, so that I will write a query select id comma name comma salary divided by 12. Okay, so this particular, that is salary divided by 12, is this is nothing but our arithmetic expression or arithmetic operation, and such kinds of operation we can include in our SQL query. Okay, so it will means the value of the salary or the every instructor's salary is get divided by the 12, and whatever the final answer will be there, so that answer or that value is appeared in the output. Okay, and that value is the temporary value. Okay, our original value of the salary which is present in the table, they are as it is. Okay, so whenever we are applying the arithmetic expression or we are using the arithmetic expression, at that time that particular relation or the table is the temporary table. Okay, and also we can also give another name to this arithmetic expression with the help of as keyword. Okay, so similarly the as keyword, it is used to rename the column, it is used to rename any expression, or it is used to rename the table. Now we have seen the where clause also. Okay, so the where clause is nothing but we can provide the condition. Okay, so in the where clause, um, uh, where clause we can provide some condition or some predicate that the tuples of the table must satisfy. Okay, suppose the query is like this: to find all the instructors in the computer science department. Okay, means in this query the condition is that the department of that instructor is the computer science. Okay, so this computer science is the value of the department name attribute. So we can write select name from instructor where department name is equal to computer science. Okay, so we can write the where clause in this fashion. Again, in the where clause we can also include multiple conditions. Okay, with the help of and or not connectives. Okay, means if I want to find out the instructors in the computer science, means name of the instructor who is in the computer science department and whose salary is greater than something 80,000. Okay, so in this case the two conditions are there. Okay, first condition is that the department is the computer science, and another condition is that its salary is greater than 80,000. Okay, so these two conditions are connected with the and connectives. Okay, so that we can write select name from instructor where department name is equal to computer science and salary greater than 80,000. Okay, so we can like this way we can write the where clause. Okay, where clause, it may contain one condition or it may contain two or more condition, and if the more than one conditions are there, then we can connect that conditions with the help of different connectives. Okay, then the third one is the from clause. So this from clause, it is our another part of the query structure, SQL query structure. Okay, so we know that the from clause, it is equivalent to the Cartesian product of the relational algebra. Okay, so this from clause, it is equivalent to the Cartesian product of our relational algebra. So in the from clause, we provide the name of the relation from which we are taking the attribute and we are taking the value of the attribute. Okay, so if the query is like this, find the Cartesian product of the instructor and the teachers. Okay, so this cross symbol is nothing but it is the symbol of the Cartesian product. Okay, but if we are implementing the Cartesian product in the SQL, then the symbol is simply comma. Okay, means we can write the query select star from instructor comma teaches. Okay, so the symbol of the Cartesian product in the SQL is simply the comma. If uh, if we will need to find out the Cartesian product of the three relations, means instructor, teaches and the course, then we can write here select star from instructor comma teaches comma course. Okay, so that comma is nothing but we are using the tuples from the two or more tables. Okay, so this particular Cartesian product, it generates every possible instructor teaches pair. Okay, we know that the function of the Cartesian product is that, so it generate all possible pairs of two tables. Okay, with all the attributes from both the relations, means all the attributes and all the values of both the relations are present in the resultant relation while performing the Cartesian product. Okay, consider if the common attribute is present in the table. Okay, consider for the common attribute id. Okay, consider the id is present in both the table, then the attributes in the resulting table are renamed using the relation name and that attribute name. Okay, we have seen this point in our relational algebra also. If the same attribute or if the common attribute is present in both the relations, then in the resultant relation we can also rename that common attribute name by first name of the relation dot name of that attribute. Okay, so here the example is instructor dot id. Okay, consider the id is common in instructor and the teacher's relation. So the instructor is our name of the relation dot id is my name of the attribute. Okay, so we can also do this while writing the query. Okay, so this is nothing but if the common attribute is present in both the relation, then we can rename the attribute. Okay, so it is about the from clause. Okay, so generally the from clause, it is for just providing the name of the relation. Okay, so in the from clause we are providing the names of the relation from which we are selecting the tuples or from which we are taking the data. Okay, so it is the example of the Cartesian product, instructor and the teacher's relation. Okay, we know that whenever we are performing the Cartesian product, so at that time we are taking the first row of the for example here the first row of the instructor relation is combined with all the rows, all the tuples of the teacher's relation. Then again the next row of the instructor relation is again combined with or it is paired with all the rows of the teacher's relation. Okay, so the output of the Cartesian product of two relation, it is quite big, means it contains the number of tuples, means all the tuples are from both the relations. Okay, then these two are the examples based on the Cartesian product. Okay, so we'll solve this example. First, find the names of all the instructors, okay, who have taught some course and the course ID. Okay, means we need to find out here the names of the instructors who have taught some courses, okay, and the course IDs we need to display. Okay, such courses course ID we need to display. So here we require the two relations, instructor and the teachers relation. Okay, because in from the instructor relation we'll get the name of the instructor, and if require the ID of the instructor. Okay, and in the teachers relation we require the course ID of the courses. Okay, and by this ID attribute is the common in both the relations. Okay, so we can say that if we uh, if we equal these two IDs, means we can say that this particular instructor, okay, means this Srinivasan whose ID is 10101, okay, and the same instructor is present in the teachers again whose ID is 10101, means we can say that this Srinivasan has taken the CS 101 course. Okay, so the ID attribute is the common. So based on this common attribute, we can say that this particular instructor has taken or has taught this particular course. Okay, so here we are selecting name of the instructor because in the query they have mentioned that find the names of instructors, comma, course ID of the courses. Okay, so comma, course ID, and we know that the name it is from the instructor relation and the course ID attribute it is from the teachers relation. So from instructor comma teachers. Okay, and we know that if we want the data from one or more two or more tables, then either we need to perform the Cartesian product or we need to perform the join operation. So here we have performed here the Cartesian product. So the from instructor comma teachers, where instructor.id is equal to teachers.id. Okay, so remember that this equality condition every time we need to provide while solving the query using the Cartesian product. Okay, so if we are solving this query with the help of join operation, then this condition it is not required. Okay, so we have seen this is in the relational algebra also. Okay, so here we are solving the query with the help of Cartesian product. So this equality condition is required. So by performing the equality on the ID attribute of both the relations, means we can say that the instructor who is present in the instructor relation, okay, so that instructor is same as who is present in the teachers relation, and that particular instructor has taken the particular course. Okay, so the query is very simple. We have solved such kinds of query with the help of relational algebra. Okay, so the same queries are there, and here we need to solve these queries with the help of our Cartesian product. Okay, so understood. So first query, so here simply we need to provide here the comma between two relations because the query is based on the Cartesian product. Okay, so similarly another example we'll see. Find the names of all instructors in the art department. Okay, so remember here the condition is that the department of the instructor is the art. Okay, and we need to find the names of the instructor. Means in the select we can in the select clause we can write the name attribute. Okay, then who have taught some course and the course ID. Okay, means who have taught some course, and we need to display the course ID of such courses. So again we can write select name comma course ID, Okay, so here also we are taking the two relations. So from instructor comma teaches, where instructor.id is equal to teachers.id. So this condition is important and this condition is compulsory because it is the Cartesian product. And one more condition is given in our query, that the instructor, the art department. So here instructor dot department name is equal to art. Okay, so we can write this way. Okay, if the department name attribute is the common between two relations, okay, means if this department name attribute is the same in two relations, then we need to write this way, means name of the relation dot the name of the attribute. Okay, means instructor dot department name is equal to art. So this particular clause or this particular statement, it says that this department name is belonging to the instructor relation. Okay, suppose in the query if they have given that the particular course is uh, the particular course is in the CSA department. Okay, so then we have written here teachers dot department name is equal to art. Okay, so in the query they have mentioned here that the instructor is in the art department, means what, this particular department name attribute is belongs to the instructor relation. So that's why we have written here like this way, means instructor dot department name is equal to art. Okay, so these two are the examples of the Cartesian product. Okay, very simple examples. So the only thing is that we need to write the comma between two relations, because for the Cartesian product, for the join, we require two or more relations. Okay, so simply put a comma between the number of relations, and one thing is that we need to provide the equality condition in the Cartesian product. Okay, so any doubt in this? Are you understanding the Cartesian product or simply the from clause? Are you understanding? Yes or no? Yes or no? Reply me. Mayuri. Okay. Okay, so it is for the basic SQL query structure. Okay, so simply we have seen the select clause, then from clause and the where clause. Okay, so I will give you today we'll solve our third experiment. Okay, that is DML queries. So last time you have created the tables instructor course etc, and you have inserted values into that tables, right? Now these are the some simple queries and you have to solve these queries now. Okay, so the first query, so I will give you some so very first query is that find the names of all instructor. Okay, so how to solve this query? Find the names of all instructor. So simply you need to use here the select clause and the from clause. Okay, so these 7 queries are based on only select, from and where clause. Okay, so you have to solve this query now. Okay, so I will give you some time to solve these queries. Okay, and you have to solve the queries. I will ask anybody to show me the output. Okay, any doubt in that? Any doubt? If you have any doubt, then please ask me. So all the queries are very simple. So simply you have to use the select, from and the where clause. Okay, so these queries are the DML queries, means data manipulation language. So any doubt in this? Yes or no? If no, then solve these queries. Okay, I will give you some time. Very simple queries are there, and if you have any doubt while solving these queries, then please ask me. The students, those who are having laptop or the machine with them, so they have to solve these queries on the machine, means using the SQL. And those who are having no laptop with them, then they have to write the queries into your notebook. See, all queries are very simple queries based on the concept we have covered. So these queries are based on that concept only. Done. Completed. At least 4 to 5 queries have you completed? Anyone has completed at least 4 to 5 queries? Madhura, have you completed? Madhura, Ahilya, Ahilya Dange, have you completed? Why, Madhura? At least some of the queries. Kajal Kharade, Kajal Kharade, see if you have written queries on paper or on any notebook, then also you can show me. Take a snapshot of that query and share your screen and then show me. Mukund Khapale, Mukund Khapale. Try to solve the queries. completed this? Yes or no?
Hello,
Huh?
ma'am. I completed five.
Okay, no problem. So you can show me. So I will stop presentation so that you can share your screen. Okay, so share your screen and show me.
But ma'am, my battery is 1%. So give me 2 minutes, ma'am.
Okay, okay, no problem. Hello Mukund, can I stop my presentation? Mukund Khapale.
2 minutes, ma'am.
Huh. So I will stop my presentation. You share your presentation. So share your screen.
Ma'am, can you see my screen?
Huh? Show me. What happened? हम्म, तो थोडं झूम करा ना. You have written it on notepad. Okay. Select name. Okay, very good. Select star from instructor. Salary greater than 90 and department name physics. What about sixth one? Salary
Ma'am,
greater than 70. Okay, very good. Good. All the queries are correct.
thank you, ma'am.
Yeah, okay. So another person, Sonia. Sonia Kagde. Sonia Kagde. Show me your queries. Sonia Kagde, are you there? Sonia Kagde, are you there? Why students are leaving the meeting? Only 34 students are here. Sneha? Sneha Lohkare. Say, I want to see at least 2 presentation. 2 presentations from the students. Who will show me? Sanskruti? Prashant. Okay. Uh, show me from first query. First query. Select name from instructor. Okay.
Yes, ma'am. Very
Second.
question.
Okay. Second query. Correct. It is correct. Department name from instructor. Okay. Next. Select where it is. Select name from instructor where salary greater than 90,000. Okay. And one more is department name is equal to physics. Okay. Show me sixth one. Okay. Select ID name, department name, salary into 1.15 from instructor. Okay. Very good. It is correct. So that query it is for the raise of salaries by 15%. No? Okay.
Yes, ma'am.
Very good. And what is the last one? Computer science and the salary 70,000. Very good. Correct. Okay. So you, Prashant, you can also rename that column. Okay. That salary multiplied by 1.15. Okay. So you can rename that column also. Okay.
Yes,
Just by writing ads
As
and new name of the column. Okay.
yes.
Very good.
Can I stop my page?
Yes, yes. You can stop.
Okay.
Okay. I want to see one more answer. Who will show me? Sonia Kagde, are you there? See, every time only 4 to 5 students are giving me answer. They are only responding. What about other students? So are you understanding or not? Other students are even not responding to me. They are not ready to give me answer. Yes or no? Diksha? Diksha Lale? Have you done this? Diksha? Diksha? Why? Why you have not solved the queries? If you don't have laptop or machine with you, then you can also write your queries into your notebook. I think Sonia Kagde is not present there. Okay. Because many times I have called her. I have written one message in chat box also. She is not responding to me. Okay. So no one is ready to show me the answers. So can we proceed? Is anyone interested to show me? If no, then I will proceed. See, today up to 5 p.m. you have to send me answers of all these queries. Okay. You can mail me, you can WhatsApp me. I want answers of all the queries from everyone. Okay, we'll start our next part. Okay, whether my screen is visible? Whether my screen is visible to you? We will start the next part. That is additional basic operations. Okay, so we have seen 3 basic operations using the select, from and the where. Okay, now the additional basic operations are rename operation, string operation, order by operation, and the where clause predicate. Okay, so we'll see first the rename operation. Okay, so the SQL, it allows renaming the relation and renaming the attributes with the help of as clause. Okay, so we have seen that if we want to give another name to the relation or another name to the attribute, then we can use the adds clause. Okay, its syntax is old name adds new name. Okay, so this old name, it is of any relation or it is of any attribute, and the new name means the new name that we want to give. Okay, so simply the adds clause, it is used to rename the operation or rename the relation. Okay, one query based on the rename operation: find the names of all instructor who have higher salary than some instructor in the computer science department. Okay, means what? Here we need to find out the names of the instructor. Okay, so the query is select distinct t dot name. Okay, so what is this t dot name or what is this t? Okay, so we'll see this. So this t is nothing but it is the new name of the instructor. Okay, so that particular query or the syntax we have written here: from the instructor adds t. Okay, means here I have renamed the instructor relation to the t. Okay, comma, instructor adds s. Okay, so this instructor adds s means another name of the instructor. Okay, because the two relations means the same relation is required two times, because in the query they have asked find the names of instructor who have higher salary than some instructor in the computer science department. Okay, so for this case we require such two relations. Okay, so we have renamed the same relation, okay, using two different new relations. First one is instructor adds t, comma, instructor adds s. Okay, then where condition, where t dot salary greater than s dot salary. Okay, so here we know that we have used here only one relation. Means what? The attribute salary is present in the instructor relation, and here we need to perform the comparison of the salary. So same salary attribute will appear in the query. Okay, and we know that if the same attribute, if the common attribute is there, then we can rename that attribute by name of the relation dot name of the attribute. Okay, so simply we have written here where t dot salary greater than s dot salary, and one more condition is that s dot department name is equal to computer science. Okay, so here instead of s you can also write here t dot department name is equal to computer science, because only one relation is provided here. Okay, so it doesn't matter. Okay, you can write t also or s also. Okay, so the simple query for that particular equation, for that particular statement is select t dot name. Okay, from instructor adds t. Okay, so the instructor adds t, instructor adds s, it is nothing but I have renamed the name of the relation instructor to the t. Okay, and if I'm using the common attribute from the relation, at that time also I will write name of the relation dot name of the attribute. Okay, so this is the rename operation. Okay, then in this query the keyword as is the optional, and it may be omitted or it may be removed. Means while renaming the relation we can also omit or we can also remove the as keyword. Okay, means simply we can also write the instructor space t. Okay, so meaning of this equation or the meaning of this query is nothing but the instructor is renamed to the t. Okay, so we can write using any one of the way: instructor adds t or instructor space t. Okay, so anyone is applicable. Then whenever we are renaming any relation, okay, so that new name, it is called as the aliases. Okay, so here T and S, these two are the aliases. Okay, so these aliases are nothing but we can say they are the new names or they are the temporary names. Okay, so the rename operation is written with the help of as keyword. So there are two options to rename the relation. Okay, the first one is by using the as keyword and another one is without as keyword. Okay, so the instructor adds T means this. Now for this particular query, this T is acting as the instructor table, instructor relation. Okay, and sometimes if the name of the relation is very large, then also or at that time also we can rename that relation so that it will be easy to write the query. Okay, if here the name of the relation is very small, then it is not necessary to rename the relation. But if some cases the name of the relation is very large, okay, for example instructors detail or instructors information, okay, if such kinds of relation names are there, then we can use the rename operation. Okay, so it will be easy while writing the query. Okay, so it is about the rename operation, very simple. Now the next one is the string operation. Okay, next basic operation is the string operation. So the SQL, it includes the string matching operator, okay, for the comparison on the string. Okay, so the string operations are means the basic string operation used in the SQL is the matching of the string or we can say substring and matching the particular character. Okay, so in the SQL, the like operator, it is used to match the string. Okay, and especially the like operator uses the patterns that are described using two special characters. Okay, so like operator, it is used to match patterns. So the pattern is nothing but suppose my input string is computer science department. Okay, so this is my input string and a particular pattern is nothing but for example science. Okay, suppose I have selected the science. Okay, so I have to check that this particular substring, that is or the science, okay, this particular pattern is appears how many times in my input query. Okay, so pattern is nothing but the sequence of characters. Okay, particular sequence of character. So to match such kinds of patterns we are using the like operator in the SQL. Okay, so the SQL includes another operators also, means the concatenation operation, then converting uppercase to lowercase and lowercase to uppercase, etc. Okay, but that is the we can say it is the advanced part. Okay, so for your syllabus you have only the like operator. Okay, so especially the like operator, it uses the patterns. Okay, and these patterns are described using two different special characters. The first one is the percentage character and the next one is the underscore. Okay, the percentage character, it matches any substring. Okay, substring means I have told that if the input query or the input statement is computer science department of college. Okay, suppose this is my input statement and a particular substring means what, science. Okay, so I want to find out that particular science keyword or that science string is appears how many times. Okay, then the second like operator is the underscore. So the underscore, this character matches any character. Okay, means if we want to find out the particular characters from the given string, then we can use the underscore. Okay, and the uh, percentage character we are using for matching any kind of substring. Okay, so simply character means the single letter. Okay, and the substring means two or more letters. Okay, so this percentage operator or the percentage character, it is used to match the substring, and the underscore character, it is used to match the any individual character. Okay. One example is find the names of all instructors whose name includes the substring DAR. Okay, means I want to find the names of instructors whose name contains DAR as a substring. Okay, so I can write select name from instructor where name like in a single quote percentage DAR percentage. Okay, so this percentage, it is for why the percentage symbol is used here, because here we need to find out the particular substring. Okay, so the substring is need to find out, so we have used here the percentage. Okay, and they have mentioned that the DAR is the substring. So that particular substring, it is written between two percentage character. Okay, so this is our query to find out the names of the instructor whose name include substring DAR. Okay, then in the string operations, the patterns, okay, that we have seen, so that patterns are case sensitive. Okay, means if in a substring or if in a query, if they have asked find out the substring or find out the names that contain the substring ABC. Okay, and that ABC, it is in the what you can say small letters. Okay, or it is in the lowercase letters, then it will match the data from our input statement, which is in the small letter only. Okay, so the patterns are case sensitive, means the uppercase letters, lowercase letters, they matters. Okay, so there are some examples of the pattern matching. First one is in a single quote intro percentage. Okay, intro percentage means what? It matches any string that beginning with the intro substring. Okay, so in the pattern matching, we are finding any substring of a given string. So if the pattern is like this, means the intro and percentage, so it is nothing but it matches any string that is beginning with the intro keyword. Okay, if in a query the condition is like this, means percentage comp percentage, means what? It matches any string that containing the comp as a substring. Okay, so the substring means what? Before that comp and after that comp, some string is present. Okay, so that's why the comp is called as the substring. Okay, and the third example is percentage science. Okay, percentage science, it matches any string that ending with the science string. Okay, so the percentage science means what? Ending with that particular string. Okay, simply remember that if the percentage character or if the percentage character appears at the end of the substring. Okay, if the percentage character is present at the end of the string, means what? We need to find out the string that is beginning with the particular substring. Okay, जर तुम्ही आधी ती स्ट्रिंग दिलेली असेल आणि त्यानंतर तुम्ही पर्सेंटेज सिम्बॉल दिलेला असेल, त्याचं मिनिंग काय? तुम्हाला काय फाइंड आउट करायचंय की कुठलीही अशी स्ट्रिंग की जी स्टार्ट होते तुम्ही जो सबस्ट्रिंग दिलाय त्याच्याने. ओके, इफ our percentage symbol is appears at the first and the last of the string also, means what? That particular string which is present between the two percentage character, so that is our substring, and we need to find out such kinds of substring. Okay, and the third case or the third example is that if the any string is present after the percentage character. Okay, if any string is present after the percentage character means what? That particular string is with uh, ending with the substring which is present after the percentage character. Okay, so these three are the examples of the patterns. Simple. The first one is if the percentage symbol is appears at the end of the substring. Okay, means what? We need to find out, or we need to match the string beginning with the string which is present before the percentage character. Okay, and if the percentage symbol is appears at the start of the string, means what? We need to find out the string which is ending with the string which is ending with the substring which is present after the percentage symbol. And if the substring is present between the two percentage symbol, means what? We need to find out some such kinds of substring. Okay, so it is for the pattern matching for the percentage character. Okay. My battery is low and I don't have charger with me, so I think we'll have to stop here today. Okay, only 10% battery is remaining. Okay, so we will cover these points tomorrow in tomorrow's lecture. So be fast. Give me present. Okay, roll number 1,
Present.
2,
Present, ma'am.
3,
Present, ma'am.
4,
Present, ma'am.
5, 5, 6,
Present, ma'am.
7, 7, 8, 9,
Present, ma'am.
10,
Present, ma'am.
11,
Present, ma'am.
12,
Present, ma'am.
13, 14, 15,
Present, ma'am.
16,
Present, ma'am.
17, 'Please write your roll number into the chat box. Okay. 18,
Present, ma'am.
19,
Present, ma'am.
20,
Present, ma'am.
21,
Present.
22,
Present, ma'am.
23, 23, 24,
Present.
25,
Present, ma'am.
26,
Present, ma'am.
27,
Present, ma'am.
28,
Present, ma'am.
29,
Yes, ma'am.
30,
Present, ma'am.
31, 31, 32,
Present, ma'am.
33, 33, 34,
Yes, ma'am.
35, 36,
Present, ma'am.
37,
Present, ma'am.
38, 38, 39, 40,
Present, ma'am.
41,
Present, ma'am.
42,
Present, ma'am.
42,
Present, ma'am.
43, 43, 44,
Present, ma'am.
45,
Present, ma'am.
46, 46, 47,
Yes, ma'am. 47.
48, 49,
Present, ma'am.
50, 51,
Present, ma'am.
52, 52, 53,
Present, ma'am.
54, 54, 55,
Present.
56,
Present.
57,
Present, ma'am.
58,
Present, ma'am.
59,
Present, ma'am.
60, 61, 62, 63,
Present, ma'am.
64, 65,
Present.
66,
Present.
67, 67, 68, 69,
Present.
70.
Present.
Okay. Absent numbers are roll number 5, 7, 13, 14, 17, 23, 31, 33, 35,
17 present, ma'am.
Ma'am, roll number 39, present. Ma'am, roll number 39, present.